Alright guys, welcome back. So today we're taking a look at 5.4, areas of triangles, which we've discussed, well not in this class, but you've discussed in the past, area of a triangle being your basic 1/2 base times height. We're going to discuss two other ways besides that traditional area formula. These will be useful for situations similar to what we've been talking about with our law of sines and law of cosines. So the two methods are the side angle side area formula and what's called Heron's area formula. So side angle side area formula is basically where you're given two sides of a triangle and the included angle, side angle side. And it turns out no matter how the triangle is labeled, whether it's using A, B, and C's or other letters, doesn't matter. The area is always half the product of two sides, the two given sides, times the sine of that included angle. So in this scenario right here with triangle ABC, area would either be half of AB sine C, because angle C would be in between sides A and B, or it's half of AC sine B, again B would be the include angle of AC, or it's 1/2 of BC sine A, A is the include angle of BC. So if we have this scenario right here, well, we can see that the two sides are the 12 and the 12.2, and that the angle is the 121 that's in between them. So our area would just be half 12 times 12.2 times sine of 121. So we just put that into our calculator, making sure we are in our degrees mode, and rounding to our usual thousandths place, we get 62.745. The units are centimeters, and because it's an area, it's centimeters squared. That's all we got to do. It's very straightforward. There's nothing really too involved with how we're finding our area. It's just a simple product. The biggest key really is making sure you're identifying the correct side and angles to work together, and that your calculator is in the appropriate mode degrees for our triangle. So that's the side angle side area formula. Now the other option is based off essentially side, side, side. It's got a special name, Heron, for the guy who worked with this. So area for this is based off the square root of S, and then S minus A, S minus B, S minus C, all that multiplied together. Where S is defined as the semi-perimeter, where you add your three sides together, A, B, and C, and you divide it by 2. So we have to find S each time first, and then we fill into the formula with our difference of S of A, B, and C, or whatever the three sides are labeled as. So here, we find our value of S by doing 35 plus 48 plus 22.1. We divide that by 2. Doing that gives us an S value of 52.55. So our area, we'd have our square roots, nice big square root, make sure there's enough room here for S. And then we're going to do each of the differences of S in those three sides. So the 52.55 minus the 48, the 52.55 minus the 35, and then the 52.55 minus the 22.1. All that multiplied together, and then square that whole big result, and that should give us 357.457, and again, it's centimeters because that's what they give us, and it's square because it's an area. And that's all we're doing. So both of them are very straightforward in setup and execution. You just have to make sure you're careful with how the calculator is being used, because obviously you're not going to do something like this one by hand, and obviously careful with the mode and everything else for the side angle side area formula. All right, so that's it for 5.4. Our last topic, Unit 5, is going to be applying the right triangle trig, law of sines, law of cosines in a word problem style format. So I'll see you guys next time for that video.